Today we talk about how we have built real-time data processing systems with Apache Kafka. A quick introduction of mine. Hi, my name is Akash. I'm currently taking care of data engineering, data products, as well as DevOps and delivery. Quick glance of delivery. What delivery is? I guess everyone is aware what delivery is. This is an e-commerce logistics company which primarily deals with B2C, B2B parcels as well as the heavy parcels, with different business segments. We have a network coverage of almost 18,500 pin codes. That is huge. With that, we have a very huge infrastructure setup, which is almost 17.9 million square feet logistic infrastructure that we have. We have spread across 4,100 centers in India. We have 26,000 plus active clients and so on and so forth. The thing is, why the real-time processing is really important in this business, because if a shipment gets delayed, then it becomes really difficult. Even the customer gets agitated because of not receiving the shipment on time. That's where the real-time systems comes in place. I've cherry-picked one problem statement that we have, especially around the large facilities, which empowers our operations. Because real-time systems are empowering our operations to quickly move shipments from one to another. Now, this is one of the facility overview that we have. This is situated in Kauru, Haryana, and this facility is that huge that if you have to walk around the facility, the perimeter itself is almost 2 kilometers. It has a shed area of almost 5.5 lakh square feet. We have a total docks where the trucks can get staged. Those are almost 131. You can imagine the facility is that huge that the truck. In parallel we can handle almost 131 trucks for unloading and loading. Similarly, we have a throughput of bag in and out, which is almost 4 lakhs in a day. Bags are nothing; it's just a group of shipments moving to one location. We just group them into a bag and then we load them into the truck. This facility primarily takes care of two operations that we have. One is the mid mile and the first mile. If I talk about the first mile, the idea is to basically pick the shipment from the seller's warehouse and process them and then sort that and put that in a bag, which is the processing center, which is part of one area which is basically doing that. Similarly, we have a hub which is moving those shipments, loading that into the trucks, and unloading those shipments coming from different locations. So that's where a lot of things which are happening here and there, and in such a large facility, it's difficult to coordinate from one location to another. That hey, where are you and where my shipment is? Which particular destination I should connect to this shipment or bag, right? So it's difficult to coordinate in such large facility, and that's where the real-time systems comes in play. So we figured out how we should do it, and that's where we plug the technology into this place. As I talked earlier in this slide, that we have almost 80 plus applications which are empowering different operations. So similarly, if we have to do it, then how we can do it. But before that, I'll quickly talk about a few of the challenges that we are facing, that we usually face in the facility. One is real-time visibility that we have. Imagine that, as I stated earlier, right? In such a large facility, if someone wants to understand how many trucks which are coming in that facility and where that truck should be placed, it's really difficult for someone to answer, right? Which particular bay is dedicated for this particular location, maybe it could be Jaipur or Bhubaneswar or something like that, right? How we can stack up those shipments, how we can stack those bags over there. And that's where, the real-time visibility plays a very important role to understand the overall facility health. It also gives the idea that, which particular bay area is free and which particular bay areas, piled up with a lot of shipments and so on and so forth. Similarly, the real-time prioritization is also very important, because if the shipment or maybe a bag is lying in a facility for quite long, then the aging is increasing, and how we can quickly prioritize that bag to immediately add into a truck and dispatch it from that location. So that's where the real-time prioritization also comes in. In fact, the truck placement, the manpower placement is also very important in terms of where we should allocate most of the manpower, and that's where the prioritization again comes in. Third thing, which is real-time facility actions, which gives our overall floor picture that, okay, how these floors are basically available for this particular location. If the particular location is piled up with a lot of, shipments of, let's assume for one location, which is Bangalore, then should we dedicate another new Bay Area for that thing or not? So there are a lot of things, a lot of decision making which happens over there. Now here the point is, we will not allow our operator to ideate every time what is happening in the facility. We will allow operator to execute things. So it's more about executing things rather than ideation. And that's where the technology comes in, where we have introduced Apache Kafka. Now, we have 80 plus applications, right? I mean, the data is coming from different sources. We have different systems, and every organization is sort of moving towards a microservice-based architecture. And the reason is fair because the data is growing very rapidly. Now, if data is growing, then usually in microservice architecture we also decouple the data sources. And if we have decoupled the data sources, we have to stream them together and provide that one visibility through one pane, right? That's where the Kafka comes in. Kafka, I guess everyone is aware that it's a distributed streaming platform that allows you to publish and subscribe to the events. Second, so I'll not stress on the Kafka side of things, I'll stress more on the Kafka Connect, which is one of the framework available that is also open source, and we have built a lot of things on top of it. Now, Kafka Connect is a framework which allows you to extract the data out from different data sources, whether it could be MySQL, Postgre, or anything, or maybe the application whatsoever is generating the data from different places. How we can stream those and put it in Kafka, and then further actions can be taken to push those events to the respective systems. And that's where the Kafka Connect comes in really well. And in fact, it not only allows us to basically stream those events, it also allows us to do a filtration, transformation, as well as denormalization over there. Now, I'll stress more on the denormalization part of thing because imagine that if we have different microservices for, let's assume, like vehicle data which is coming from vehicle application, right? We have a data of attendance coming from different, from HRMS, or maybe if we are getting a data from, for a person who's, there from one different app. So if we have to, enrich the data, enrich the information, then we have to merge all these events together. And if we have to do it from the analytical point of view, the traditional way is to basically dump everything into data lake and then join it together. But the problem comes in over there, because if you try to do a later processing, by the time you cannot take action on top of it, the information could have been stale. So the idea is to basically denormalize on the fly rather than doing it later stage. And that's where the denormalization part we have leveraged a lot over here. We have done a lot of state store transformations, and this not only helps in driving real-time analytics that we have. Now, it also allows us to do a ETL sort of a thing, which extract the data from the data sources, do a transformation, and then load into that respective system. Similarly, microservice architecture. Because if a microservice is consuming data from 3 different sources, they will integrate with 3 different areas. I mean, it's really difficult for a microservice to build that logic inside, and if that logic is should be reusable for any other microservice, it's difficult to even share that logic. So the idea is, why don't we denormalize everything at one place and then allow anyone to subscribe and then take actions on it. And you can keep on further denormalizing again and again. You can funnel them down to one plane, because ultimately data warehouse likes a data to be combined together so that the OLAP or the analytical processing can be much faster. So it's a glimpse of the architecture that we have, right? We are getting from the data from work allocation app, vehicle routing app, bag information app, put app, mid-mile application, and all are streaming data into a system, and that's where we are extracting this information from the change streams. Now, after extracting this information from different change data capture based connectors, we put it into Kafka, and from Kafka we do a streaming analytics and we dump everything to TiDB. I'll talk more about TiDB later, but that's where we store that information there. On top of it, we have a lot of dashboards built which are empowering this thing. I'll take a further deep dive into this architecture further. And this is sort of it's really difficult to read, I guess. But if I start from the left, there are different producers which are there, right? These producers are sort of like data sources that we have. These data sources belongs to the corresponding application. What is that application is basically using that particular database. It could be MongoDB, it could be MySQL, Postgre, and we don't, ask anyone to stick to these data sources. They can use anything, and that's where the Kafka Connect ecosystem, provides a list of connectors which allows us to extract that information from these different sources. There were a few data sources which were not there or maybe were slow in the Kafka Connect framework. We created our own connectors over there. For example, Mongo Change Stream connector that we have developed. The DynamoDB connector, that's sort of like not open source, so we have developed that on our own. And similarly, we have users of the available connectors in the ecosystem. DBZM is one of the examples. I guess some of them probably have heard of. Now, after extracting this information through these change data capture connectors, we dump this information into Kafka. We don't put any sort of a logic, we just dump it in an unstructured form, because these data can come from SQL or NoSQL based data systems. Now, the SQL is sort of very well structured because the data types and everything is sort of taken care in the database itself. But in case of NoSQL, if there are sparse keys or if there are any keys which are getting created on the fly, it's really difficult to keep a track of the data type corresponding to it, because for analytical processing, you need the data types to be consistent across all the events which are getting in. So here we have introduced a schema registry, which is Kafka provided schema registry, and there we have make this data compliant to our schema what we have. And with that help, we have again created another Kafka topics with a structured data set that we call it as schema compliant data set, and we have started putting it over there. Whatever which is not schema compliant, we just stream those data sets into data queue for the later processing to figure out what is wrong over there, right? Now with that, after that we do a denomination. Now the denomination is something which really need, because if you think of like joining a data in a stream, it's really difficult to even think of, right? But it's not even difficult, it's really easy in streams in fact. Because if you start keeping a state of one of the data set, for example, as I taking one example of vehicle attendance and manpower systems which are generating data and how we can keep that, then you can store one data set into Kafka store, but you have to be cautious about what is the life cycle of that event, and that's where we have defined those life cycles in a way that the data should get trimmed whenever the corresponding job is done. So with that lifecycle policy, with that state stores, we have leveraged the Kafka state store APIs, which is KStore, and have created developed things on top of it. And further, we have got one common stream of all the three different sources of vehicle attendance and manpower systems to one, and there it's really easy to compute things on top of it. It not only reduces the effort of aggregating things at a later stage, which we traditionally do it in data warehouse, which always like a denormalized data set. It also helps in empowering some of the microservices which are dependent on taking those decisions of merging those data together, right? So with that, we have started putting this data into TiDB and we have started putting data into TiDB, and there we have created data marts. Now these data marts are real-time data marts that we have created, which keep on getting refreshed and which allows us to empower the corresponding dashboard. Now, if I talk about TiDB a bit here, TiDB allows us to do both OLTP and OLAP processing. That's the reason that it is called as ESHA database, which is hybrid transactional analytical processing. The reason of introducing that is because we cannot keep accumulating the data or maybe keep appending the data just like our traditional data warehouse we usually do. We have to keep on doing the upsert, which is sort of a transaction system is basically been designed for, but at the same time we have to do analytics on top of it, and that's where the combination of both comes in. It's a So with that help, we have start plotting those dashboards, which are some of them are on QuickSight, some of them are on in-house dashboards that we have developed, and with that we have empowered a lot of things around the same. Now what it brings, this overall thing. Now going back to the problem statement that we had, real-time visibility, real-time prioritization, real-time in-facility actions, how we are empowering those, that's where things comes in. So we have dashboards that contains data from different sources, we are getting information of shipments, vehicle, manpower situation on ground, whatsoever is there. Put away percentage of how we are keeping the shipments on ground into one place, that which gives a overall picture of the facility. And in fact, it gives the operator to understand, okay, how my facility is getting utilized. Similarly, we have a traffic control dashboards, which are basically prioritizing the loading of trucks based on different factors, whether it is aging, whether it is expected time of arrival, or anything that sort of, which changes the flow of the network, right? So with that, again, it's more about taking a decision on top of it rather than ideating things, right? So the operator is quick to execute things given that the high volume is coming in, right? Another use case that we are solving is the outbound dashboard, which provides a real-time information of the bags, and also gives a visual cues of the trucks which are there, that for which particular destination they should be staged for, right? So these are the things that we are driving through this. And if we don't have such real-time systems in place, then we'll end up having suboptimal utilization of resources, because think in a way that if someone is shouting to another person like, where are you, and just take this shipment away from here, it's really difficult to navigate inside the facility. So that's a thing like what real-time system brings in. Yeah, that's the end of my presentation. Happy to have any questions if anyone has. Yeah.